Alright guys, today we're finishing up that electric charge array. That was your homework tonight, so we can finish doing some of the graphing of this tomorrow. And so we went ahead and we calculated the force by taking our Coulomb's law constant, which was our 9e to the 9th, and multiplying it by our cell B3, which is the charge of our first particle. That's my particle. You'll be using whatever your first charge was. So if you had Q1 as your group, that's what your charge is. Mine was Q4, so that's my charge for the first one. And I stuck the dollar signs there because that's the one I want to calculate the forces with all these other ones. That's what I want to calculate the forces with against all the other ones. So I'm taking B3, which is mine, to B4, which is charge 1. And that's going to give me my next one. I divide by I4 squared. That's the distance, the total distance squared. That's our radius. And so it's K Q1 Q2 over R squared is our formula. And that gives us the force. And I've just added the wrong thing here, so I'm going to delete that. Hit enter, and I get negative 4 to the 0.34 times 10 to the negative 32nd power. And that's not a very big force, but these are not very close together. So I can click and drag those down and make sure that our numbers then are going to be scientific. Now I wonder what's going on with that one. This is one of the issues we have. I5 is correct. B3 divided by B5 or times B5 and J. Oh, it's J10. I didn't add the J, the dollar signs for J's, so I need to dollar sign that J. Or what I'm going to do is I'm just going to call this 9E9. And that way it's there and it's already calculated, and it actually goes ahead and calculates it for me as 9 bajillion. So I'm going to drag that one down. And there are my forces. Now I need to figure out the forces in the x direction. And to do that, I need to drag this over a little bit. And I want to find the force in the x direction. And so the force in my x direction is going to have to do with the distances as well as the angles. And so what we're going to have to do is think about this in 3 dimensions. Or rather in 2 dimensions. So I'm going to go here. And so what we're going to assume here is that we have a triangle being made with each one of these charges. And so if this is my charge, this is Q4. And I apologize, I'm typing or doing this at my computer instead of on the board. But if this is Q4 and this is the Q in question, right? This is my other Q. My X distance and my Y distances correspond here. And I want to find what this theta is. So if I want to find theta, I know I need to use my trigonometry rules. And so my tan of theta is going to be equal to my opposite over my adjacent. So that's y over x. And these are my y over x distances. Now if I want to find what my theta actually is, because that's what I want, I need to take the inverse tan. So the inverse tangent of y over x gives me theta. And so to find my forces in the y and the x direction, I need to find that theta, and then I need to take and use my sine and cosine rules. And so remember, if this is our force that we just calculated based on the distance between the 2 charges, our force components are going to be based on this guy right here. Now you might be thinking, why don't I just use this vertical distance to find my force and use that as my radius? Well, that's not actually the radius. The radius is from here to here. And so what we have to do is we have to find this force, which we've just found, and then we go in and we find what these are by breaking them down with trigonometry rules.
Will Elder come to the office, please? Will Elder to the office?
And obviously I'm doing this after school instead of before school or during smart lunch or my planning period. So I apologize for that. Once again, we're going to find this the force components in the y and the x direction using our force component of the hypotenuse, which we've just calculated, based on this total radius in between. And so what we want to do is to find x, to find our f in the x direction, we want to take the cosine of theta, because it's the adjacent level. So we take our...
to be in Coach Williamson's room ASAP. All varsity wrestlers go to Coach Williams' room immediately. Thank you.
Go, Kaylin. We take our force, and we go and we take our cosine of theta, which we calculated over here. To find our y, in that y direction, we take force times the sine of theta. And so if we find those, that's how we're going to calculate this. So let's go back over, and I'm going to show you how to use your spreadsheet to calculate the sines. So I'm actually going to add an extra column in here and call this theta. And we're going to go ahead and calculate what our angles are. So the angle here is going to be the inverse tangent. So we're going to use the equal sign. And with the equal sign, we're going to type in tangent. However, if you look at this, it says the tangent of an angle provided in radians. We don't want the tangent, we want the inverse tangent. And so, but it's going to calculate that. The inverse tangent function is an atan. And it gives me the inverse tangent here in radians. It gives me, I can get the arctangent, or I can get the inverse hyperbolic tangent of a number. Well, we want our inverse tangent, but we need it in degrees. And so we go ahead and instead of putting atan right away, we put degrees. And then have our parentheses. And it's going to give us that inverse tangent. And so we put degrees first, I think. Let's make sure. Yeah, we want degrees. And now we want atan. And we want the inverse tangent of y over x. And so those are our y over our x over here. And so we've got our y distance and our x distance. So let's see, here's our y distance divided by our x distance. And that gives us closed parentheses. We close the other parentheses, and that should give us a theta, which is going to be negative 15. We know that's not going to necessarily a negative all the way, maybe, because my number is all the way at the bottom, but it's going to be to the left, basically. So we're going to look at that. Now we want to take these and find a different one. I think we might actually be able to. We might be able to drag this down, and so that gives us H4 over I4 or over G4. Yeah, there we go. And then these are our angles. So we get 86 degrees. That looks about right. That's a nice almost 90-degree angle if you look at your graphs, the 4 to number 5. So those look approximately correct, and they're going to be all negative, basically to the left of vertical, or rather up from the horizontal to the left of vertical. And so those are our thetas. And so now I want to plug these in to find my f of x, my force in the x direction and my force in the y direction. And the way I'm going to do that is using my sine tools. And so once again, sine is going to give us radians, and we want degrees. So let's go ahead and put things in degrees. So the way we're going to do this is we're actually going to have to calculate using radians. So remember, we basically did that here. We found our that's wrong. When we were over here, we turned our radians into degrees, and so that's our degrees. So what we're going to do is we're actually going to then just recalculate theta in radians so that we've got it. And so we're going to say that equals radians, and that one right there. So we'll convert those to radians, and now we can use our trig rules to turn these into our other values. So f of x is going to give us the f cosine of theta, and so we've got equals this times cosine of this in radians What are you doing? What are you doing to me? We need to do it this way. Multiplied by our force. And that should give us our force in the x direction. We'll drag that one down. And now we need to find our force in the y direction. That's going to be found with our sine values. So this is going to be equal to our sine of this multiplied by our force, which is right here. And that gives us our force in the y direction. And you notice that those look approximately the same. If we were to take the square of this and the square of this, we could probably find this right here. And that gives us those values. So now that we have these forces in the x and the y direction, we can actually look and draw those components, which is what we're going to do tomorrow. And so as we look at that, you guys should be able to see some of that. So one of the things that I want you to notice is that this is a negative. All right, this is a negative force. And so if we look at the interaction between our Q4 and our Q1, Q4 is a positive, Q1 is a negative, which means those are going to be attracting. So an attraction is probably going to be this negative. So we'll look at that value and we'll look at those to see what those values are going to be. So see you guys tomorrow. Good luck finishing these formulas, and pause the video while I'm writing the formulas and you should be all set.